Okay, so what we're going to be doing today, guys, is the lab is going to be on using position versus time graphs, specifically using a position versus time graph to calculate the average velocity of a cart. Okay, we are going to run 4 carts down the hallway, but the carts are not the manipulated variable. Okay, I realize there are 4 different carts, but we're only using 4 different carts for the purpose of getting more practice doing the graphing stuff. We are not comparing the carts in this lab. Okay, what we are looking at is what's the relationship between the position and time of an object that moves at a constant velocity. Okay. Now, yesterday, you made a graph of position versus time for an object that pretty much was traveling at a constant velocity. What did it look like? It was a straight line. What kind of relationship produces a straight line? A linear one. Okay, that might be important. Okay, this is probably going to be a linear relationship. We've talked about that before because if something is going at a constant speed, it travels the same distance every second. Okay, or from a vector perspective, it changes its position by the same amount every second. Okay, is that making sense and kind of sounding familiar to everybody? Yes? Okay. So that's the problem we're investigating. What's the relationship? Okay, so we kind of got a spoiler there. All right, our hypothesis. We want to generate a hypothesis about the relationship between distance and time for an object traveling at a constant speed. Now, we just said, what the relationship was. What part of the hypothesis should that be? Probably the if, okay? Okay, so in the if part, we should talk about the relationship they have, and we know what that is. Okay, the and part's going to describe the experiment. Now, this experiment is wrought with experimental error, okay, with procedural error. It just is by its very nature. All right, so when we're doing the lab, kind of make note of a few things that could possibly be sources of error for you later. Okay, but essentially what it's going to be, and honestly, guys, I spent 6 hours here on Saturday morning trying to find a way for you guys to do this virtually. So I could be at the hospital with my son today, but it just wouldn't work. So we're going to have this measuring tape laid out on the floor of the atrium. And we're going to guide the carts along the tape. And when I say guide, I mean that. They don't go straight. Okay? Okay. And there's a couple of reasons they don't go straight. First off, of the 10 carts we bought in 2006 when we moved here, there are 4 left that work. Okay, so that gives you some idea of their condition and age. Okay, the other thing is that if you've ever looked closely at the floor in this school, anywhere in this school other than the portables, you've probably noticed that it's not level anywhere. There's like humps and bumps, and it used to be worse. Believe it or not, the floor in the atrium has been pulled up 3 times since we moved here because it's so uneven that the floor just peels away. Okay, and the reason for that was when they laid the concrete, the guy on the trowel, the power trowel, they got the wrong kind of concrete and it set too quickly, and he wasn't able to power trowel at level before it set on him. Okay, at first we figured maybe the person on the power trowel was just drunk because that's kind of what it looked like, but then we found out later that they just had the wrong kind of concrete. Anyway, it means that the floor is not level. And if the floor is not level, imagine going over humps and bumps like in a cart that's trying to go straight. What's it going to do? Yeah, it's going to turn. It's going to push it. Gravity's going to pull it to one side or the other because it's kind of like, going along the side of a hill. Okay, so there's some places, and things that are going to result in the cart wanting to change direction. We don't want it to. Okay, so what you're going to have to do is the person who's the pilot, that's the term for the person guiding the cart, by the way, okay, you're going to walk along with the cart between your feet. And when it starts to get off track, you're just going to give it a little nudge, not a swift kick, a nudge, just to keep it on track with your feet. Okay, I'm making it sound a lot more complex than it really is, but we do have to keep it on track. All the while, there will be 2 people who will be responsible for measuring the time and the position of the cart. So the person measuring the time, that's easy. You'll just use the watch, the stopwatch app on your phone, okay? And the person who's marking the distance, or the position, sorry, will be placing a yellow sticky note on the measuring tape, marking the position of the cart every 5 seconds. Is there any error in that? Yeah, quite a bit. Okay, that's just the nature of the beast. That's what we have. That's how we're going to do it. All right. To be consistent, of course, we will always use the back of the cart, okay, as the kind of measurement distance. And whenever we place the yellow sticky note on the measuring tape, okay, so here's our measuring tape, we'll just say. Every time we place a yellow sticky note on it, so it'll be a little rectangle like that, we will measure from the leading edge of the sticky note, right? Because if we're going sometimes from the leading edge and sometimes from the back edge, we bring in the size of the sticky note as a source of error, and we don't want that. We have enough sources of error already. Everybody follow on that? Okay. We're only doing 4 carts, okay? So once the cart gets going and the marks are down, then what you should be doing, or actually probably what I'll do is, as the cart is going, I'll just walk behind it and start reading the numbers off to you. All right, so the person will be laying the sticky notes down and I'll read the numbers off the sticky notes. That way it's always me looking at the notes, okay, and giving you the measurement. All right, so that's the description of the experiment. That was a lot of talk for the and part of the hypothesis, but okay, that's how that's going to work. All right, in the then part of the hypothesis, I want you to tell me how, using your graph, you'll calculate velocity. Okay, using the graph. Okay, how using the graph you will do that. All right, not using a formula like V equals D over T. Using the graph. Okay. There's something from the graph, from a position versus time graph, that tells us velocity. We talked about it last week. It was the day, one of the days I was here. Okay, and I went over that. I'm not giving that one away. That one you guys have to find or figure out for yourselves. All right, so our design here, our variables, okay? What variable always goes on the x-axis? Manipulated, responding, controlled? Manipulated, okay. We're making position versus time graphs. What's going on the x-axis? Okay, now, are we actually like manipulating time? No, but we are determining the measurement interval and the length of the experiment. In that way, that will determine and affect how far the cart can go. Okay, so you don't want to write in there as your reasoning because it's on the x-axis. Okay, don't write that. I just said don't write that if anybody writes that, so help me. Okay, the reason it's manipulated is because we're determining a couple of things about it, and that will affect the responding variable, and the responding variable will be the position of the carts. Okay. All right. Controlled variables. As I was describing the experiment, I mentioned a few things that we wanted to make sure we kept the same throughout the experiment. Some of them had to do with measurements, okay, things like that. So I want you guys to come up with 3, okay? I've given you manipulated and responding, so I'm going to have you guys come up with the controlled, okay? 3 of them, remember, we got to explain them all. I still have people who are not explaining all the variables. Okay, I want an explanation for manipulated and an explanation for responding, and each controlled variable explained. Okay, in those explanations, how it affects the lab, how you're controlling it. Okay, things like that. Right, all those things need to be mentioned in there. Okay, so because we're doing this inside, that part about being the runner, you don't have to worry about, because sometimes when it's nice, I do this outside, and we just go on the track. That's a little easier than the carts, but it's cold outside, and I don't want to go out there. Okay, so we're going to have not 8 timers, but 1 timer, and we're going to have 1 person, like we said, who's putting the sticky notes down on the measuring tape as we go. Okay. So what you're going to do when we have the data all filled in, and where are you going to fill the data in? Right, so you're going to have to make a Google Sheet. I didn't include one in here, all right? So you have to make your own, which isn't hard, okay? You just go into Google Sheets and click New, okay? Or blank spreadsheet, and you can open one up and you can just put your data in, right? What needs to go in the first column? X-axis. X-axis goes in the first column, so that's going to be time, okay? And then all the carts in the columns after that. So cart 1, cart 2, cart 3, cart 4, okay? And we're recording every 5 seconds, all right? So when you start making up your chart, and we're probably going to have to do that before we go out there because we'll just take the computers out with us, okay? Every 5 seconds is what you're going to need your time to be, and then cart 1, 2, 3, and 4. Meters. Yes, time should start at 0 because that way we'll have a time of 0 and a position of 0 for each cart. Oh, I'm not going to give you the control variables. But you're asking me for one. You're saying, would that work? Will that be the same? And I'm saying, I'm not going to tell you. Yeah. Okay. But it's good. You were very persistent. I like that.
So in the procedure, we put in sheets for all 4 of the cards and tables for all 4 of the cards?
No. You're going to put this all in one chart, all on one sheet. Time, first column, then go cart 1, cart 2, cart 3. Okay. I'll outline it here in just a sec. I'll show you. Okay. Okay. Then you'll have, once you've built your graph, then there's some questions to do with it. First question is just like an algebra question. It's just asking you to manipulate y equals mx plus b for slope. All right, so it's asking you, do you remember what part of that equation stands for slope, and can you do the algebra required to isolate it? All right, you don't have to put in any numbers. I just want to see y equals mx plus b manipulated for slope. That's all you have to do for question number 1. Okay. Question number 2, okay, using the equations for each car. Remember, Google Sheets spits those out for you, okay? For each car, calculate how far each car would travel in 150 seconds. Okay, we've gone over how you do that, okay? In fact, there was an example where you did it yesterday, okay, when you were working on those. And then number 3, okay, using the equations for each car, calculate how long it would take each car to travel 100 meters, okay, using the equations. By using the equations, I mean the equations from the graph. There is no place on this lab where I should see this. Okay, there's nowhere on this lab where I should see that formula. This should be done entirely by graphing. Yes, you can. So the question was, can you input photos of your work on paper? Absolutely. Here's how you do it. Okay, same as we did for the plant lab and the lab diagrams, except you don't have to go into Google Drawings. Okay, just have your work on a piece of paper, snap a picture of it with your phone, send that to your Google Drive, insert it into the document. Okay, if you want to do that for the analysis questions, that's fine. Okay, I know it's kind of cumbersome to do all the subscripts and everything with the keyboard. Okay, so if you'd rather just do it on paper and then snap a picture of that and insert the picture, that's great. Okay, that people do that all the time. Okay, there's absolutely nothing wrong with doing it that way. Okay. All right, then remember, for a conclusion, same as always, restate the hypothesis and explain how you would accept, why you would accept or reject it. Okay, again, you want to go back and refer to your observations and your analysis. Okay, and then sources of error. Okay, we'll be watching for those. And remember, you don't have to do the class discussion. We'll talk about those when you hand in the day after you hand in the lab, and I go over it with you in class. Okay, now, in terms of making up our Google Sheet. Okay, so if you're in your Google account, okay, like so, just click on a new tab and click on Apps. Okay, Google Sheets will be there. Open it up. Okay, just open up a blank one. Okay, and you can title it later if you want. I'm not going to need to see this spreadsheet. Okay, because you're just going to copy everything over into your lab report. So you don't need to add this or include it with what you hand in at all. I just need you to copy and paste the graph and the chart over. Okay, so what we should have set up like this is time in seconds. Okay, and then down below that, 0, 5, 10, 15, 20, 25, 30, 35, and 40. The experiment is only going to run for 40 seconds. Okay, so again, we are determining the length of the experiment and the measurement interval. Okay, and then for this, we'll have position in meters, and we can just call that cart 1. Right, and you saw yesterday that sometimes you go past the edge of the thing, so you just pull that and make it a little bit longer, right? And then obviously we don't have any data for that yet, but then you'll have right next to that, right, position in meters, whoop, cart 2, okay, and then do the same thing for 3 and 4 in columns D and E, right? That you guys need to have set up before we go into the atrium, all right? Okay, so once I've got these all kind of filled in, so I've got position in meters, cart 3, okay, position in meters, cart 4. Okay, now I want to put these into a graph. Notice, guys, and this is really important, I don't have seconds or meters in any of these number fields here. If you do that, Google Sheets will mess it up. Okay, it gets really confused when you have numbers and letters in the same field and it's trying to graph it because it doesn't know what to do. Okay, so I'm going to highlight all of it. Okay, highlight all of it, go to Insert, Chart. Okay, and then like it always does, it brings up the crappy chart editor. The old one's better. Okay, and of course it picks a bar graph like it always does, which we don't want. Okay, we want to go to Scatter. All right, and there we go. Okay, that looks exactly like our data because we did have two carts that were almost right on top of each other in terms of their position data, which means their velocities are also going to be pretty much the same. Okay, and that's okay. There'll be a slight difference maybe, but they'll be pretty close, and that's okay. That happens sometimes. Okay, now obviously, guys, there's some things we're going to need to do here. This title is no good, so we go to customization, right? And I would just say I would call this Graphing Lab, and then maybe in brackets position versus time. Okay, you can leave the legend over where it is. It's fine there. Okay, our left vertical didn't get a label because obviously we have 4 things on there, so it doesn't know what to do. So we'll just label that position in meters. Okay, and then it'll do that. All right, we don't really need to change anything else, but we're going to go down to series, and you're going to want smaller points. Okay, because as you can see, the green points and the yellow points are right on top of each other. So having smaller dots will be really useful here. So I would change them to 2px, okay, and then put in your trend line and put in your equation, right, so that we've got what we need there, right, and then do that for each one of the carts, right. So do the same thing for that, make it 2px, okay, put on the trend line, use the equation. Right, and you can see we're getting that graph to form here. Okay, so same thing for each one. And here will be the telling tale as to these 2 carts. Okay. Once you put it in there. Okay. Well, I mean, we'll have the equations on. That's what's really important. Nope. Okay. Well, they are, I mean, there is one number that's the same for both, but there is another number that's slightly different because not all of their points were identical. Okay, but they were close enough, obviously. So, all right, once you have that, okay, then just click update, okay, and that graph is coming over into your lab report, okay, but before that comes over into your lab report, the chart needs to come over into your lab report. So click on an empty field, okay, highlight up here, highlight all of your data, and copy it, either Control-C or go up to Edit, okay, doesn't make any difference which way you do it. And then right here where it says procedure, copy and paste your Google Sheets table and graphs. So Okay, I'm going to paste the table in there, and I'm going to link it. Okay, and it all came through, well, except that the formatting's kind of weird here for whatever reason. Okay, so that came over nicely, and then I'm going to put the graph in right underneath that by copying it over. So I'll highlight, click out of this box here, okay, and then copy the chart and bring it over into here as well. Come on. Oh, we're going to be like that, are we? Yeah, I want you, yeah, because if you go back and make any changes, you want them to be reflected. Okay. Sorry, for some reason it didn't come over here, but there we go. Okay. Then you've got all of your, that's your observations and data. Okay. You got that over and it looks like that. That's 3 out of 3. Okay. For your observations and data. All right. So I'll leave the rest to you guys. You got the rest of class here to work on it.